Hello everyone, welcome to MemoNeet. I am Aprajita, your chemistry SME. So how are you all doing? I hope everybody is doing good. So students, this is your second lecture on thermodynamics. Okay, so in the last lecture, I hope all of you have watched the first part of thermodynamics. If not yet, so you can watch that because your exam BPT 7 is on Sunday. So this chapter is going to come in the exam. This is a pretty easy chapter if we understand it well. Okay, so in the last lecture I have discussed the basic terms that are used in thermodynamics. Okay, all the terms we have discussed, the basic concepts, and after that we studied about the first law of thermodynamics. Okay, the work done, everything we did in that lecture. And today we are going to learn the concept of enthalpy. So enthalpy is the first thing that we are going to study. All right, and then we will talk about entropy change and all of that. All right, so students, do you remember I gave you a question in last lecture to solve? So I saw only 3 comments in the video. It means only 3 students have solved that. So please try to solve the questions that I am giving you, and if you are solving, please do comment. Okay, so this was your question which we did in the last class I gave you. So the thing is that you have to keep in mind the sign conventions. Okay, so first of all, it's given that 701 joules of heat is absorbed by the system. So you know that whenever heat is absorbed by the system, it is going to be positive. All right, and if heat is released by the system, then the sign of Q would be negative. Similarly, work done by the system, if the system is doing the work, all right, so it is going to be negative, and work done on the system is going to be positive. Means if the surroundings are doing the work on the system, it is going to be positive. So now in this question we have to find out the delta U. So Q, now Q is 701 and heat is absorbed by the system, so here Q will be positive plus 701 joules, and the work done is done by the system, so it will be minus 394 joules. So here I will put the value 701 minus 394, so it will come out to be 307 joules. Simple. This was very simple question that you have to solve. I saw 3 people gave the answer and they gave the right answer, that is 307 joules. Okay, so it has to be positive. Keep that in mind. So if you are not taking the right sign conventions, it might come out to be wrong. So see, these 4 things you have to remember: heat absorbed, heat released, work done by the system, and work done on the system. Okay. So now let us talk about the concept of enthalpy. So this is the new term that we are introducing. Okay, and in the last lecture we have studied that heat absorbed at constant volume, means delta U is heat absorbed at constant volume is equal to the change in internal energy of the system. But all the reactions, or you can say most of the reactions, they are not carried out at constant volume. Okay, but they are carried in flasks or test tube under constant atmospheric pressure, means their pressure would be constant. Okay, so you need to define another state function which can be used in this condition where pressure is constant. Okay, so now let us recall the equation for delta U. So delta U is QP minus P delta V. Now I am rewriting it because now we are considering it at constant pressure. तो अगर constant pressure पे consider कर रहे हैं, so in subscript I am writing P and P delta V is the work done. Okay, minus P delta V is the work done by the system, and QP is the heat absorbed by the system. Now let's say if there are two initial and final states, so the internal energies will be U1 and U2 respectively. So if you have to find out the change, so U2 minus U1 will be QP minus P V2 minus V1. Now you have to arrange the terms. QP को हम one side ले जाएंगे and U2 plus PV2 it will be, and minus U2 minus plus PV2 PV1 sorry 1. Okay, so now यहाँ पर अब इस function को, that this thing that we are getting U plus PV, इसको हम another, we define it as another function which is your enthalpy. So which is denoted by H. Delta H means the enthalpy change. So H is equal to U plus PV, and so this equation becomes QP is equal to H2 minus H1, okay, which is equal to delta H. So H2 is U2 plus PV2 and H1 is U1 plus PV1. Now you know कि जो heat है Q, it is a path dependent function, but enthalpy is a state function. So you need to know these things also, कि which property is a state function, which is a path function. Okay, why? Because enthalpy depends on U and PV, all of which are your state functions: internal energy, pressure and volume. So all these are state functions, and H is U plus PV, so it is also going to be a state function. Means the value of enthalpy or enthalpy change will be independent of the path followed. It will just depend on the initial and the final state of the system. Okay, so in this case you can say QP is independent of the path, heat at constant pressure. Okay, so now for finite changes at constant pressure, we can say delta H is equal to delta U plus P delta V, sorry, delta PV. Okay, so P is constant, so we can write delta H is equal to delta U plus P delta V. Alright, so it means whenever heat is being absorbed by the system at constant pressure, means we are measuring the changes in enthalpy. So keep that in mind कि delta H is equal to QP and delta U is equal to QV. Okay, these two things you have to keep in mind, because now here let's learn more about delta H. Now delta H value is negative for exothermic reactions. You know exothermic reaction mein heat is evolved. Okay, so delta H for exothermic reactions would be negative because heat is released, and delta H for endothermic reactions jahan par heat is absorbed from the surroundings, it is going to be positive. Okay, now this different delta H and delta U, it is not significant for the system of only solids or liquids, because solids and liquids do not have any significant volume change on heating, right? Delta V आ रहा है ना, so there will be not any significant volume change, but it becomes significant where we are talking about the gases. So in terms of gases, you need to have an equation. So let's say if I am having a reaction involving gases, VA is the volume of the gaseous reactants and VB is the volume of the gaseous products. Similarly, N is the number of moles of gaseous reactants and NB is the number of moles of gaseous products. So you can write the ideal law equation: PVA is equal to NART and PVB is equal to NBRT. Now instead of PVB and minus PVA, okay, so we can write NBRT minus NART. So यहाँ पे हम लिख सकते हैं NB minus NA into RT. So this is the change in number of moles which I can write as delta NGRT. So P delta V की value क्या आ गई? यहाँ से we can write P into VB minus VA. So P delta V is delta N RT. Now this delta N subscript G refers to the number of moles of gaseous products minus number of moles of gaseous reactants. So keep that in mind, we are just talking about the gases. So यहाँ से you get an equation that is delta G is equal to delta U plus delta NGRT. Instead of P delta V, I have written delta NGRT, but it is valid for gases only. So this can be asked in numerical. So keep this relation in mind. Okay. Now, next important term that we will be studying is heat capacity. Okay. Now, how do we measure how much heat is transferred to the system? Now, whenever heat is transferred, okay, whether it is released or absorbed, you can see the temperature change. Okay, when heat is absorbed by the system, what will happen? A rise in temperature will happen. Okay, so increase in temperature is proportional to the heat transferred. So you can say कि जो increase in temperature है हमारा delta T and heat transferred, they are directly proportional to each other. Okay, now यहाँ पर there will be a proportionality constant. Okay, now this proportionality constant is denoted by C. Now this C is known as specific heat, or you can say heat capacity. Okay, specific अलग से बोलेंगे. This is heat capacity. Okay, now this depends on the size, composition and nature of your system. Okay, so it means कि we can measure the heat supplied by monitoring the temperature rise and if we know the heat capacity of that system. Okay, So when the value of C is very large, so there will be like a given amount of heat will result in only a small temperature rise. Okay. So ki water has a large heat capacity. So a lot of energy is required to raise the temperature. Okay. Now this C is directly proportional to the amount of the substance. Okay. So if I have to find out the molar heat capacity, means for 1 mole molar heat capacity, it will be denoted by Cm, means C upon N, means the heat capacity of 1 mole of any substance. Try to understand these terms. Okay, these are the basics that we are learning. So this molar heat capacity, you need to know the definition. It is the quantity of heat needed to raise the temperature of 1 mole of a substance by 1 degree Celsius or 1 Kelvin. Okay. So this is molar heat capacity. Now what is specific heat capacity? That is also different. Now specific heat capacity means the quantity of heat required to raise the temperature of 1 unit mass of a substance. There we were talking about 1 mole. So here the amount of heat required to raise the temperature of 1 unit mass of a substance by 1 degree, or you can say 1 Kelvin. So it will be specific heat capacity. Okay. So here, for finding out the heat Q required to raise the temperature of a sample, we will multiply the specific heat of the substance C by the mass and by the temperature change. Okay. So means this is capital C. Alright. Specific heat capacity जो है, like whatever for 1 unit mass, और फिर जितना mass है उसे multiply कर देंगे, we will get the heat capacity of that sample and then we will multiply it with delta T. Now students, there are like two heat capacities, like we have discussed now, QP and QV, right? Heat यहाँ पर हमने discuss करी है. So what we can do here is we can take the heat capacity at constant pressure as Cp and heat capacity at constant volume as Cv. So according to the previous relation, that is Q is equal to C delta T. So we can say that here QP will be equal to Cp delta T and QV will be equal to Cv delta T. Constant pressure and constant volume. And just now I told you to remember some results, that is this one, that QP is equal to delta H and QV is equal to delta U. So let us move ahead and put the values. So QP is equal to delta H and QV is equal to delta U. Okay, now for ideal gas, what you can say is, just now we have discussed delta H is equal to delta U plus delta PV, right? So for ideal gas, or here we are taking 1 mole, all right? So keep that in mind. We are taking 1 mole of an ideal gas. So PV is equal to RT. So instead of PV, you can say it will be equal to delta RT. Now R is constant. So delta H is equal to delta U plus R delta T. Now put the values of delta H and delta U, these ones. So delta H is Cp delta T and this one is Cv delta T plus R delta T. Now delta T is common, so you can cancel it out, right? So you will get Cp is equal to Cv plus R. So यहाँ से we get a relation which is Cp minus Cv is equal to R. Now this is the most important relation, you have to keep that in mind. इस पे based पे questions आते हैं, that is Cp minus Cv is equal to R. R is the gas constant. Okay, so keep that in mind. And how we have derived it, I have also shown you that. Now students, we will be seeing the enthalpy change for the reaction. Now till now we discussed what is enthalpy. So you know that whenever a chemical reaction happens, reactions are converted into products. Okay, so the enthalpy change that is accompanying the particular reaction is known as reaction enthalpy, and this is the symbol that we write, delta H for the reaction. R means for reaction. Okay, now how to calculate this reaction enthalpy? So reaction enthalpy is sum of enthalpies of the product minus sum of enthalpies of the reactant. So this sigma means summation, okay, sum. and A and B are the coefficients, stoichiometric coefficients. All right. So let's take an example. You will understand it more in more better way. Let's say I am having methane plus 2O2 gives CO2 plus 2H2O. So here enthalpy of the reaction will be the enthalpy for CO2, which is your product, plus 2 into enthalpy of water. 2 means this coefficient, okay, minus enthalpy of the reactants, which is methane, enthalpy of methane, plus 2 into enthalpy of oxygen. Now this HM means the molar enthalpy. All right. So this is how we can find out the enthalpy of the reaction. Now you need to understand what do we mean by standard enthalpy of the reaction. So like enthalpy of reaction we have understood, right? Standard enthalpy means that enthalpy change for the reaction when all the substances are in their standard state. Okay, standard state means in its pure form at 1 bar. Okay, 1 bar pressure. Let's say if I am talking about standard state of liquid ethanol at 298 Kelvin is pure liquid ethanol at 1 bar. Okay, means if I am talking about solid iron at 500 Kelvin, it's pure iron at 1 bar again. Okay. So this is how we find out the enthalpies. Now we need to understand other concepts of enthalpy also. So enthalpy changes during phase transformations. Phase transformation means whenever your one phase is changing to another, solid to liquid, liquid to gas. Let's say if I am talking about melting, okay, so you know कि जब melting होती है energy changes are involved, okay, because you know कि ice will require heat to melt and that will convert to water. So this melting takes place at constant pressure, which is your atmospheric pressure, and during phase change you know temperature remains constant. This you have learnt in lower classes na ki when ice is being converted to water, at that time the temperature will remain constant, means 273 Kelvin, means the temperature will not change until whole of the ice has been melted. Okay, so for this reaction the enthalpy that we will be writing means the energy change, okay, we will be writing is as FUS and minus. Now we are talking about standard state, okay, यहाँ पर this sign is for standard state. All right. So means you can say the enthalpy change that accompanies melting of 1 mole of a solid substance in standard state is called standard enthalpy of fusion, or if I am talking about molar 1 mole, so molar enthalpy of fusion. So this is your standard enthalpy of fusion. So like it is 6 kilojoule per mole. All right. So here this delta H is positive. It is telling us that heat is required for the reaction. Of course, heat is required for melting now. Alright. Now if water will freeze, process will reverse and equal amount of heat will be given out to the surroundings. Okay, वहाँ पर sign negative हो जाएगा. Right. Same goes with vaporization also. So melting, you know, it's endothermic, so all enthalpies of fusion are positive, I told you. Okay, now water also requires heat for evaporation, and at constant temperature means at boiling point it changes. Constant temperature, constant pressure. So यहाँ पर we the enthalpy change that we'll be writing will be the enthalpy of vaporization. Okay, standard enthalpy of vaporization or molar enthalpy of vaporization, which is required to vaporize 1 mole of a liquid at constant temperature and constant pressure. So again it is positive, means heat is being required here, absorbed here. Now you know sublimation, where directly solid changes to vapor, like solid carbon dioxide. वहाँ पर भी heat will be required. So here like for dry ice it's given, for naphthalene delta H is given. So in that case the enthalpy change will be known as the standard enthalpy of sublimation. Okay. Now this magnitude of enthalpy change, now what is the magnitude ki how much energy is required? Of course you know ki if you want to convert a solid to liquid, so how much energy is required depends on the strength of intermolecular interactions of the solid. whatever solid it is, right? Like in case of water, you have strong hydrogen bonds that hold them tightly. For acetone, the intermolecular dipole-dipole interactions are weaker, so वहाँ पर less energy would be required. Means 1 mole of acetone will require less heat to vaporize than 1 mole of water, right? So that depends on the intermolecular interactions. All right. Now, if I talk about standard enthalpy of formation, so standard enthalpy of formation, okay, it is, you can say, the standard enthalpy change for formation of 1 mole of a compound from its element in their most stable state of aggregation is called standard molar enthalpy of formation, and delta HF से इसको हम denote करते हैं. Okay. कि when 1 mole of any compound is being formed from the elements, now those elements must be in their most stable state, okay? So that energy, us time pe whatever energy change is there, that will be your enthalpy, standard enthalpy of formation, okay? So like for example, here we have taken some reaction like H2 plus half O2 gives H2O. So I am writing delta HF is minus 285.8 kilojoule per mole. Okay, so for 1 mole we have to take now. Keep that in mind. For 1 mole we have to take. Like here for methane, this energy is given. All right, for C2H5OH ethanol की formation के लिए the enthalpy of formation is given. Now keep that in mind that the standard enthalpy of formation for an element in reference state means most stable state is taken as 0. Okay, in its most stable state that will be taken as 0. Now let's say I'm having this reaction, calcium carbonate gives calcium oxide and CO2. So if I want to calculate the enthalpy, like reaction enthalpy, so यहाँ पे to calculate the reaction enthalpy, we can use the standard enthalpy of formation. So reaction enthalpy, this is again very, very, very important. Keep that in mind, okay? That the standard enthalpy of reaction will be equal to the enthalpy of formation of products minus the enthalpy of formation of reactants, okay? So that means like for this particular reaction, the enthalpy of reaction will be enthalpy of formation of product means calcium oxide plus enthalpy of formation of CO2 minus enthalpy of formation of calcium carbonate. So if we know these enthalpy of formations, I can calculate the enthalpy of this reaction. So it means this enthalpy is coming out to be plus 178.3 kilojoule per mole, means this much energy would be required to break down this calcium carbonate. Okay, means it's an endothermic reaction that we also get to know from here. All right, students. Now the next thing is thermochemical equations. So these equations that we are writing, no, the balanced equation together along with the value of delta H, where we are talking about the enthalpy of the reaction also, it is called thermochemical equation. Chemical equation तो हमें पता है, balanced chemical equation. If we are mentioning the enthalpy also, so that becomes the thermochemical equation. Okay. Like for this, here I have mentioned the delta H for the reaction. It is describing the combustion of liquid ethanol and negative sign indicates that it's an exothermic reaction. तो ये आपको याद रखना है that negative enthalpy means exothermic reaction and positive means endothermic reaction. Now you need to know some things because इसके basis पे numericals आते हैं. Okay. So these coefficients, whatever we are having, they refer to the number of moles, not the number of molecules. Okay. Now this numerical value of this delta HR refers to the number of moles of substance specified by an equation. Now what does that mean? Let me show you. Let's say I'm having this reaction here, Fe2O3 plus 3H2 gives 2Fe plus 3H2O. So यहाँ से we can find the standard enthalpy of formation. Now iron जो है, it is in its solid state, मतलब standard state में है, most stable state, तो enthalpy of formation for iron would be 0. Okay. Similarly, hydrogen is in gaseous state, which is the most stable state यहाँ पे. Okay, तो elemental state में है. So elemental statements 0. For H2O it's given, for Fe2O3 it's given. Now delta H for the reaction we can calculate 3 into like enthalpy of product minus enthalpy of reaction hota hai na, so 3 into enthalpy of H2O minus 1 into enthalpy of this Fe2O3. So from here you will get minus 33.3. If I write this reaction in another way, now like how, let's say if I am balancing it like this is also balanced by dividing it by 2. Okay, so yahan par again you will find out for this reaction. So the value is coming out to be minus 16.6. Means it is changing because I told you it will depend on the number of moles that are participating. Okay, so this shows that enthalpy is an extensive quantity. Remember intensive and extensive property. Extensive property means that will depend on the amount of the substance. So यहाँ पर it is changing with the number of moles, means it depends. And you know, if a chemical reaction is reversed, the sign of delta H will also be reversed. Like for N2 plus 3H2 gives to NH3. Here it's an exothermic reaction. If I reverse it, it becomes endothermic. Okay, of course, you know कि अगर forward reaction exothermic है, then the backward reaction will be endothermic. So sign would be reversed. Okay. Now next important topic is Hess law of constant heat summation. So students, just now we have seen that enthalpy is a state function, means change in enthalpy is independent of the path followed, means it will just depend on the initial state and the final state. So it means we can say that enthalpy of the reaction will be same whether it is occurring in one step or it is occurring in a series of steps. So this was stated in the form of Hess's law. So here we can say it states that if a reaction takes place in several steps, then its standard enthalpy of reaction is the sum of standard enthalpy of intermediate reactions into which overall reaction may be divided at the same temperature. Okay, so S law is important because iske basis par questions come in Neet, like they will give you 3 to 4 reactions and they will give you one reaction then. So then using those 3 to 4 reaction, you have to find out the delta H for that one particular reaction. So like here we have this reaction graphite, it burns to carbon, of course it burns to form carbon monoxide. So यहाँ पर carbon monoxide is the major product but carbon is burning now, so we can't say कि only carbon monoxide will be the product, carbon dioxide will be formed. Okay, so we can't measure the enthalpy for the reaction directly. So what I am doing is I am taking two reactions where carbon and oxygen combine to form CO2 and carbon monoxide reacts with oxygen to combine to form CO2, and the enthalpy of these reactions is known to us. Now we will combine these two reactions in such a way so that I get this first reaction. Okay, now you see I want to have carbon monoxide on the product side, so I will reverse the second reaction. Okay, so if I reverse the reaction, just now we have discussed if we will reverse the reaction, the enthalpy sign will change. So instead of minus 283.0, it will become plus 283.0. Okay, so if we add equation 1 and 2, so on adding again we will add this equation first and the third equation जो हमने निकाली after reversing the second one. So we will add them up. So see carbon, this is the first equation and this is the third one. So half O2 and O2 है, तो it will be half O2 on the reactant side. Carbon dioxide will cancel, opposite side पर है, and we will get the required reaction. So enthalpy would be added. So see, using Hess law, we have calculated the enthalpy change for the reaction. So उस reaction को we have divided into two steps and then using that we have calculated the change. Okay. So these are the enthalpies, like different names that we give for these enthalpies. Okay, like for standard enthalpy of combustion means enthalpy change per mole of a substance when it undergoes combustion. Okay, where all the reactants and products are in standard state. Like here if I talk about cooking gas in cylinder, so it is denoted by delta HC. C will be written for combustion. So here butane gas is burning to form carbon dioxide and water. So this is the balanced equation, and the delta C is given here. Delta H is given, means this is the enthalpy of combustion, means this much energy would be released when butane will burn. Okay. Next is enthalpy of atomization. So atomization again means whenever atoms are being formed. So here hydrogen gas is being converted to hydrogen atoms. So here also again enthalpy is, so now to break the bond, enthalpy like energy is required, so that's why the enthalpy is positive in this case. Okay. So enthalpy change here we will be calling it as enthalpy of atomization, means the enthalpy change on breaking 1 mole of bonds completely to obtain atoms in the gas phase. Okay. Same goes with bond enthalpy. Bond enthalpy also, you know, students, ki whenever bonds are formed, energy is released, but when bonds are broken, energy is required. So let's say if I am having 1 mole of dihydrogen gas, 2 atoms. So if I want to find out the bond enthalpy for the HH bond, ki how much energy is required to break this HH bond, it is 435.0 kilojoule per mole. So this is the bond dissociation enthalpy of this HH bond. Okay, means it is the change in enthalpy when 1 mole of covalent bonds of a gaseous covalent compounds are broken to form products in the gaseous phase. Okay, so of course it will be same as the enthalpy of atomization of dihydrogen. There is no difference, no, here there is no difference. All right. But if I talk about polyatomic, so for diatomic molecules, enthalpy of atomization and enthalpy of bond enthalpy or bond dissociation enthalpy would be same. Now if I talk about polyatomic molecules, now here methane break down to form carbon and 4 hydrogen. But you know that in methane there will be 4 carbon hydrogen bonds, right? So if I want to calculate the bond dissociation enthalpy of carbon hydrogen bond, I can't just say ki this is the bond dissociation enthalpy, right? Because this is the energy required to break the 4 bonds. Okay, but of course the 4 bonds are identical in bond length and energy, but the energy required to break them is different. So for the first one it's 427 kilojoule per mole, then 439, 452 and 347. So I will be adding them up, and after adding them up I get 1665. Now if the bonds are identical in this case, so this is actually mean bond enthalpy of CH bond that we will be calculating. So now this is the total energy required to break the 4 bonds. Okay, now to break 1 bond, what will I do? I will divide this by 4. Okay, so when I divide this by 4, I'll get 416 kilojoule per mole. So means this will be the bond dissociation enthalpy for the CH bond. So here the bond dissociation enthalpy and the enthalpy of atomization is not same. This is the enthalpy of atomization, okay, 1665. But the bond dissociation enthalpy would be different. Now if I talk about enthalpy of solution. Now enthalpy of solution may what we need to understand is, it is the enthalpy change when 1 mole of any substance dissolves in a specific amount of solvent. कि जब हम dissolve कर रहे हैं, whenever dissolution is happening, then what is the energy change in that case? Enthalpy change. Okay. So enthalpy of solution at infinite dilution. I hope you know what is infinite dilution, okay? Like we have studied molar conductivity at infinite dilution also, right? So where the concentration is very less, we are using infinite amount of solvent. So it is the enthalpy change observed on dissolving the substance in infinite amount of solvent when the interaction between ions are negligible, because at that time solute molecules are negligible only, na, infinite dilution, so their interactions will also be negligible. Okay, so at that time that enthalpy will be the enthalpy of solution at infinite dilution. Okay, now what happens is ki when ionic compound dissolves in solvent, now those ions are like present in the crystal lattice, no, like if I talk about NaCl, so there is this crystal lattice that is present, like there is this ordered arrangement minus plus, है ना, these ions are there. So when they are dissolving in the solvent, those ions are leaving their ordered position on the crystal lattice. Now they are free to move in the solution, and then the solvation of these ions will happen. Means you can say ki hydration in case of water. So hydration ho jayegi. So what will be in the enthalpy in this case? So this is the enthalpy of solution. So enthalpy of solution will be the lattice enthalpy plus enthalpy of hydration of ions. So दोनों add करके, because two energy changes would be there na, solvation and lattice enthalpy would be there. So we will be adding them up and we will get the enthalpy of solution. Now what is this lattice enthalpy then? So lattice enthalpy of ionic compounds is the enthalpy change which occurs when 1 mole of compound dissociate into ions in gaseous state. Like sodium chloride is there solid, okay? So when it is dissociating into sodium ions and chloride ions in gaseous state, so at that time whatever energy change, enthalpy change happens, we call it as lattice enthalpy. Means that lattice is being broken down na. So that's why we are calling it as lattice enthalpy. So we cannot calculate the lattice enthalpy directly. So we have to construct a enthalpy diagram which is called Born-Haber cycle. Very important. So let's say first of all what happens, we are taking sodium which is in solid state, it is converting to gaseous state. So here what is happening? Sublimation of sodium. So we know the enthalpy of sublimation for sodium, that value I have written. Now that sodium atom which is present in the gaseous state, it will convert to sodium ion, means it will lose the electron. So you know that energy required to remove an electron from an isolated gaseous atom is the ionization enthalpy. So यहाँ पे that delta H जो होगा, the enthalpy change will be the ionization enthalpy. So 496 kilojoule per mole energy is required. Okay, same goes with chlorine. First of all, dissociation of chlorine will happen because chlorine exists as a diatomic molecule. So chlorine gas ka dissociation hoga, okay, to form chlorine atoms. So here it will be, of course, what will it will be, because chlorine we are breaking the bond na, so it will be bond dissociation enthalpy. Now that bond dissociation enthalpy ka bhi half hoga, because we are talking about just one chlorine atom, hame one chlorine atom chahiye. So it will be half of bond dissociation enthalpy of the chlorine bond. So it's 121 kilojoule per mole. Now this chlorine atom will gain an electron to form chloride ion. So at that time, you know, when an electron is gained by an atom to form a negative ion, energy is released. That is called electron gain enthalpy. So that will be negative. Okay. And in the fifth step, now those ions, अब हमने ions बना लिए हैं, those ions will combine to form NaCl. Okay. Now the importance of this Born-Haber cycle is that sum of enthalpy changes round the cycle is 0. Okay, so we will apply Hess law. Now इस reaction को हमने series of steps में किया है, तो series of steps में करेंगे, it will be getting added up. So just add all these four energies: 108.4, 496, 411. Okay. So 122, 121 and minus 348. All right. So just add it up and you will be getting 788 kilojoule. Okay, now this is what we have calculated when sodium ion and chloride ion combine to form NaCl, but we are talking about this thing NaCl, which is giving you Na positive and Cl negative. Okay, so now we will be using this lattice enthalpy value to calculate the enthalpy of solution. So lattice enthalpy plus the enthalpy of hydration, which is minus 78.4. So that will be calculated from the literature. Okay, the obviously like already determined values. So it will be 4 kilojoule per mole. So you can say the dissolution of NaCl is accompanied by very little heat change. So बहुत कम heat change हो रहा, only 4 kilojoule per mole. Here you can see students कि this is the Born-Haber cycle that we have for NaCl. Okay. Fine. So this is how we are calculating it. Now next important topic is spontaneity. So if I talk about spontaneous processes or spontaneous reactions, these are irreversible processes and may be only reversed by some external energy. Means these are those processes that happen on their own, okay, without any external agency. Without the requirement of any external agency, they happen on their own. So we will be calling them as spontaneous processes. So now in this chapter, we have another important term, entropy. So entropy is actually the measure of degree of randomness or disorder in the system. Ki how much randomness or disorder is there in the system. Greater the disorder, higher will be the entropy. Okay, so how for chemical reactions we are considering this entropy? So let's say if I am having a solid, liquid and gas. So solids are the ones which have the most ordered arrangement. You know, atoms or जो भी particles हैं, they are arranged in a well-defined manner. So they have least entropy. Then liquids की उससे ज़्यादा, and then for gases, they have the highest entropy because the degree of randomness is highest for the gases. All right. So students, if I talk about a chemical reaction, if this, okay, so if the structure of the product, if I am talking about the product, so those products, they have much disordered arrangement than the reactant. So we say ki there will be resultant increase in entropy. Okay, the entropy of the system is increasing. But again, if the products have more ordered arrangement than the reactants, so there would be a decrease in the entropy. Okay, means decrease of regularity means there would be the decrease lesser entropy. Okay. Now, you know, for any given substance, the solid state, crystalline solid state will be having the most, like lowest entropy means most ordered arrangement. Now, how to quantify this entropy? So, you know, whenever heat is added to the system, what happens is the molecular motion increases, particles start moving more randomly, and they increase, there will be increase in randomness. Okay, so it means the heat has randomizing influence on the system. मतलब हम entropy को relate कर सकते हैं with heat, right? Now you know कि distribution of heat also depends on the temperature at which heat is added to the system. Means if a system is at higher temperature, it will be having greater randomness than the one that is at the lower temperature. And you know temperature is the measure of average chaotic motion of particles. So if heat is added to a system at lower temperature, it causes greater randomness than when the same quantity of heat is added to at higher temperature. So it means that the entropy change will be inversely proportional to the temperature. So हम entropy को define कर सकते हैं Q reversible upon T. Like for a reversible reaction, we are writing heat upon T. So the total entropy change for any system and surroundings for any spontaneous process is greater than 0. Or it should always be greater than 0, means entropy change would be positive. Alright, this is also called the second law of thermodynamics. Ki for an universe, the entropy change should also be always be positive. And you know, whenever a system is in equilibrium, entropy will be maximum and the change in entropy would be 0. Okay. So you can say that entropy for any spontaneous process increases till it reaches the maximum, and at equilibrium the change in entropy would be 0. Again, entropy is a state property. It will not depend on the path. Okay. So delta S system will be Q system upon T. Okay, and for reversible and irreversible expansion of ideal gas under isothermal conditions, you know delta U is 0, but the delta S means the entropy change is not 0 for irreversible process. Okay, so it means we can say कि delta U cannot be used to discriminate or differentiate between reversible and irreversible process, but delta S can be. Okay, so now we have to have another quantity. So we have lots of quantity in this. Now you know for a system, it is the total entropy change, means delta S total, which decides the spontaneity of the process. Okay, so for most of the means agar spontaneous process hoga, delta S must be greater than 0. But you know कि most of the chemical reactions they are happening like either closed system or open system. Okay, so closed system and open system में there will be change in enthalpy also and entropy also. Okay, so it means neither the enthalpy, decrease in enthalpy is there na for spontaneous process, you know. So neither decrease in enthalpy nor increase in entropy can determine the direction of spontaneous change. So we have to combine both of these, and we have made another quantity which is Gibbs function, which is H minus Ts. It's an extensive property, keep that in mind, depend on the amount of the substance, and it's a state function. So delta G will be delta H minus T delta S minus S delta T, and you know at constant temperature delta T would be 0, so delta G will be delta H minus T delta S. Okay, so we can simply write that delta G will be equal to delta H minus T delta S. So delta S total will be delta S system plus delta S surroundings. And now if the system is in thermal equilibrium with the surroundings, okay, then the temperature of the surrounding will also be same as that of the system. So increase in enthalpy is equal to increase in enthalpy of the surroundings will be equal to decrease in enthalpy of the system. So यहाँ पे आप लिख सकते हो delta S of surroundings will be delta H surrounding upon T, means minus delta H system upon T. तो आप total लिख सकते हैं delta S total will be delta S of system plus delta S of surroundings. Okay, so if you rearrange from here, you will get T delta S total will be equal to T delta S of system minus delta H of system. Now you know for spontaneous process delta S total is positive, so T delta S minus delta H system will be positive. Okay, so यहाँ से आप लिख सकते हो minus delta H system minus T delta S should be positive, so it means minus delta G would be positive, or delta G should be less than 0, means delta H minus T delta S should be less than 0. Okay, so delta G is, if it is negative, then the process is spontaneous, and if delta G is positive, the process is non-spontaneous. Okay, so this was the last topic, Gibbs energy change. Alright, so try to remember these results that I have told you, ki when the process will be spontaneous, when it will be not. Okay, so with that we have completed all the important topics, all the topics of this chapter. So try to revise all the questions present in your NCERT, complete the PYQs of thermodynamics as well, and in case you are having any doubts, you can ask us in the group or in the comment section also. Okay, so students, that's it. Try to watch both the videos and solve as many questions as you can. So thank you so much. Take care.